Okay, good morning, everyone. You're all very welcome to this Foresight webinar this morning, looking at all things green steel and net zero steel, both here in the UK and globally as well. My name's Tiernan Phipps. I'm a conference producer here at the Foresight event and Foresight events. It's my pleasure to welcome you all this morning. I'm going to be moderating the session this morning and leading the conversation. We've got four fantastic speakers this morning who I'm going to introduce in turn in a moment. But yeah, it's great to have you all here this morning for this conversation. As we all know, steel kind of sits at the center of the net zero transition. We need it for all sorts of things, renewable energy, transport, housing, grids, infrastructure. It's a core part of our industrial base here in the UK, and yet steelmaking itself is, accounts for around 7 to 8% of our global CO2 emissions. And that tension kind of makes steel one of the most strategically important, I think, areas in the net zero transition, and one of the most difficult sectors to decarbonize. And that's really what this conversation this morning is all about, looking at the strategies, the projects, and also the recommendations for making green steel a reality, and also the norm here in the UK and globally as well. We'll also be looking at what's already happening and where we're seeing signs of progress in that area as well. But we'll also talk about what does need to happen as well, and where policy and regulation, I think, needs more focus as well, to make these projects a reality too. As I mentioned, very fortunate to be joined by four excellent speakers this morning. I'll introduce them all in turn now, and then very briefly, and then I'll let them do it a bit more justice themselves in terms of who they are and who they work for. But please do pop any questions you have for our speakers into that Q&A function you see at the top of the screen, as and when they come to you. As always with these sessions, we'll bank them for the end, and I'll be able to ask the questions to any of the speakers you wish to hear an answer from. So very quickly then, who have we got this morning? We're joined by Frank Askov, who is Director of Energy and Climate Change Policy at UK Steel. Great to have you, Frank. We're joined by Paolo Carvalho, who's Managing Director of Decarb Value. Paolo, great to have you as well. We're joined by Joachim von Schiel, who's Global Director for Commercialization at Lind Group. And finally, we're joined by Andrew Forth, Head of Policy and Advocacy at the Climate Group, who are also doing some really great work around Steel Zero and green steel as well. So Andrew, delighted to have you join us as well this morning. As I said, I'll let you guys give a bit more information about who you are and who you work for as well in your opening remarks, but great to have you all this morning. Final thing from me, just as a reminder, this webinar this morning, as usual, it's sponsored by the Foresight event, our all energy clean tech show taking place in February next year, 4th and 5th of February. If these conversations are of interest to you, please do consider joining us then. We've got over 45 amazing speakers on the lineup for that conference. It's looking across the whole energy ecosystem and also the industrial landscape too, looking at all the policy mechanisms and projects and things that are happening around the net zero and industrial transitions. So please do consider joining us then as well if this is of interest. But for now, green steel, really excited to get into the conversation this morning. Frank, I'm going to hand over to you now to kick us off. You're very welcome. Please go ahead.
Thank you so much, Tiernan. I really appreciate it, and great to be here today to talk at this event. Hopefully my slides will appear any moment now, but just while we wait for that, the UK Steel is the trade body for the steel industry in the UK. We represent the steelmakers kind of operating within the British market, and operate on kind of work trying to get government to kind of improve the business environment so that the steel industry can decarbonize a bit easier. So I seem to have some, so hopefully now you could be able to see my slides. Okay, fantastic. So I'm mindful of time, so I'm just going to speed through them to give you a brief overview of some of the key challenges that the sector faces. So just on introduction, kind of like effectively this has already been said. Most people here will already know this, but steel is essential to a low carbon economy. It is basically in everything, or is used to make everything. Is in and there's no way really to get to a net zero economy without decarbonizing steel in many ways. Even if you look at kind of just the energy sector alone, steel is absolutely essential to that. There was a study here a couple of years ago from McKinsey for the EU Commission, where I looked at what kind of materials are critical to everything from geothermal, nuclear, energy networks, wind, solar, EVs, and steel was the single kind of material that's important to everything. And I think copper was the second one, really. But as you can see, it's regardless of what route you're going to go down, you will need steel, and therefore there's no way really around it. Just similarly as well, kind of offshore wind turbines of this kind of size, again, you could be up to 85% steel as well. So really steel is essential. And I think this, we've already touched upon this. So the downside to steel is it's very carbon intensive to produce. About kind of 8% of global emissions. In the UK used to be about 3%. It's about half that now, just because of Tata Steel having closed down their site in October while they invest in a new electric arc furnace. So yeah, looking at the decarbonisation options, again, this is very kind of broad spectrum. So just let's start from a UK perspective on the ambitions that are being set out. So first of all, we have the government's overall kind of overarching net zero target that was agreed by the previous Conservative government. That basically requires all steel to be decarbonised within 25 years. That has been supplemented by a recommendation by the Climate Change Committee that we need to kind of decarbonise the ore-based sites by 35, so only 10 years from now instead, so much more ambitious. And the Labour government pledged a 3 billion investment in the steel industry to decarbonise it, committing to lowering industrial electricity prices and saying it must never mean deindustrialisation either. And finally, from a steel perspective itself, we very much believe that a partnership between government, unions and industry is absolutely necessary to bring investment here and to decarbonise the sector. So looking at pathways, so broadly speaking, again, oversimplification, but it does help us kind of understand where the sector's at and what pathways going forward. So here on your right, you have our report we wrote in 22 that set out the route for decarbonising the sector. Broadly speaking, there are 3 ways of decarbonising the steel industry. There are many more, but like this is broadly it. So you were looking at first of electrification through electric arc furnaces, where you melt usually scrap with electricity. It's an established technology. It's been around for almost 90 years, older than blast furnaces. Already kind of exist here in the UK. It's implementable within 5 years, so a very quick route to decarbonisation. Then you have carbon capture, again, where you basically retrofit a carbon capture plant onto existing blast furnaces, or invest in new blast furnaces where the capture rate can be a little bit higher. This is particularly important for maintaining kind of primary steelmaking capacity, or being able to decarbonize primary steelmaking, and it really is again implementable within a 5-10 years from when decisions are being made. So a little bit slower than electric arc furnaces, but not too kind of within the spectrum of what the UK government was considering and the Climate Change Committee was recommending. And then finally, you have the more hyped and modern kind of technology, hydrogen-based steelmaking, where you use hydrogen in a direct reduced iron plant combined with an electric arc furnace, and use hydrogen instead of coal for the iron making part. It's an emerging technology, as I've said here. What some of the key challenges is about infrastructure and cost parity. From a UK perspective, we don't believe this is implementable before 35. You're probably looking at 20 plus years, realistically, not based on the technology itself, but based on costs. And this is our key concern, is that basically hydrogen is very expensive and the UK has very high energy prices regardless. So we don't believe it's feasible to have hydrogen-based steelmaking in the UK in the short term. In the longer term, there are you could potentially see it again, but you do need some of the fundamentals to change. So we have Tata Steel. UK is already investing in electric arc furnace in South Wales, and British Steel has previously published plans to invest in actually both a CCUS and electric arc furnace, but their latest one was in electric arc furnace technology. But again, we'll see what happens with British Steel as they find a new owner, hopefully. If we go down the electrification route, you'll have a fully electrified steel sector with 6 to 7 electric arc furnace sites throughout the UK. Some of the challenges for the sector in terms of making this transition is around trade intensity. Get mindful of time, so I will speed through this. Very trade intensive sector, one of the most trade intensive sectors out there in terms of manufacturing. In the UK alone, we kind of export and import quite a fair bit. One of the key challenges is that where we face a dissimilar level of carbon pricing, with over 90% of the world still not facing any kind of comparable carbon costs whatsoever, which is very challenging when we in the UK face very high carbon costs and will increasingly do so as free allocations are reduced. And that means that, again, it will be very expensive and you are at a risk of being outcompeted by imported high emission steel. So, and again, steel's standardized, compete on price. This is really one of the other challenges is around the global excess capacity. So a couple of years ago, we estimated it at about $500 million, which is got 70 times the UK market, where we saw again expansions in Southeast Asia and the Middle East that don't really match domestic demand. Chinese demand has since reduced quite significantly, enormous export levels. And this basically leads to the lowest kind of profitability in a decade and depressing investment into the sector. So quite challenging again, and particularly because the new investments are blast furnaces, majority blast furnaces. So and again in countries without any kind of net zero targets before, like either kind of later than 2060 or none at all. So quite challenging from that perspective. Furthermore, kind of business case, if you're looking at kind of operational cost for CCUS and hydrogen, usually are higher than existing production, which in itself is challenging. You require significant capex investment of at least 1 to 2 billion per site usually, and again, kind of governments across the world are now investing significantly in kind of co-financing steelmaking capacity and decarbonising steelmaking capacity. And of course, UK has now done the same for Tata Steel's electric arc furnace investment. And again, we are potentially looking at further investment in the UK for British Steel or others, but that really is a bit challenging. Final kind of overall challenges around energy prices. So steel is kind of, from a UK perspective, our electricity prices are relatively high, even after the most kind of recent government action. So here's just our analysis from earlier this year, which looked at once the latest initiative by the UK government is implemented, we would still pay up to £12 per megawatt hour more than our French or German competitors. And while that has been lowered, obviously, to the £12, previously we're looking at 18. They're still higher, and it's partly due to the different generational mixes, meaning that we pay up to 25% more than just Germany and France, ignoring Sweden, ignoring the Middle East, the US, China, etc. The bar is quite low here, and we still can't meet it. So it is quite challenging. And again, just why that is so important, just because steelmaking is incredibly electro-intensive. Again, kind of electricity costs can be up to 180% of GVA for certain UK steel producers. In the UK, we use about kind of electricity compared to equivalent to 800,000 homes, and gas about 400,000 homes. So just put it into perspective. So, and therefore, kind of like from our perspective, really, regardless of what way you do need to deal with electricity prices, because all routes to decarbonisation will require higher energy consumption overall, electricity consumption in particular. Electrification, you would triple a site's power generation and more than double it for the whole sector. If you're going down the hydrogen route, you're looking at significantly more. And again, even CCUS would require significant energy losses when capturing emissions. So you would see more electricity needed there as well. So it really is essential to attracting investment to decarbonise that. So mindful of time, so I'm just going to skip this. Ultimately, again, it's quite a new number of policies we need and demands and support investment partnerships, but it is possible to actually mitigate kind of our contribution towards climate change, secure jobs, etc., etc. You can see all the benefits here. And with that, I'm going to end my slides and let another speaker come in. Hopefully that was useful. I'm very happy to take questions afterwards, and hopefully people have already written some down in the Q&A. Thanks so much.
Frank, thanks very much. Really, really interesting overview there. Kind of tells us where we are, especially here in the UK. I've certainly got some questions myself, but I'll keep them till the end. I can see a couple in the Q&A already, so that's great. I'll just remind people, do pop your questions in if you have any. But for now, Paolo, I'll hand over to you. You're very welcome.
Hi there, can you hear me well? I hope so, yes. So thanks again, Tinan and Sophia and the Foresight Events team for the invitation. My name is Paulo Carvalho, Managing Director of Decarb Value. It's a pleasure to be talking to you today. I'll be mindful of time as well to allow as much as questions and answers after the speakers come in. And having heard about decarbonisation in the UK and the challenges and initiatives, I'm happy to take a step back and look from a market perspective of what green steel is and what green steel poses in terms of opportunities for the industry to decarbonize. So this is basically the end point of the journey of decarbonization in terms of products and market presence for the products that have already seen some decarbonization. And I'll update everyone on some of these topics as well. Just a few words about Decarb Value. So we are a commercial and market advisory firm operating in the iron steel space, involved in decarbonization advisory, both strategy and scope 3 and customer decarbonization, but also CBAM, project financing and equity investment around green steel. Today, I'm going to be talking about definitions, market examples, and emerging labels. I'm going to quickly mention the EU CBAM on opportunities for green steel. Of course, we could have a whole webinar on CBAM, especially after the announcements of yesterday, but I'll just briefly mention one example. And then I'll finalize with some thoughts around the value chain drivers for the green premium on steel and steel products. So what does green steel look and feels like? Green steel has the same chemical, metallurgical, and physical properties as conventional steel. The only difference is the environmental footprint, especially the carbon emissions footprint. So these are pictures of actual green steel products that are out there. So you can see coils produced at a very decarbonized level. In Europe, you can see steel sections painted in green, but they are actually produced at a very low carbon footprint in Germany by a prominent steel maker. You can see household pans sold in shops in Italy under the green baked label. Also, if you look very carefully in the image, there is the logo of a very known brand in green steel by one of the key European producers. And even you can go on websites and you can type green steel watches and you can buy for 200 euros or so a watch produced by decarbonized steel in Sweden as well. So these are things that are tangible. They look very much the same as any other steel related products, but they will have very differences in terms of carbon footprint. The terminology out there, though, is very confusing, right? So of course, we talk about green steel openly and broadly, but there's no universally agreed definition on any standard of green steel anywhere in the world. The only exception of that will be India, and I'll talk about that in a minute. We see terms like low carbon steel, low embodied carbon steel, low emission steel, and again, used very generically without a specific use or definition. Terms like net zero steel or carbon neutral steel are also observed, and they relate to the use of offsets to kind of cancel the remaining emissions associated with the process. Sometimes they are certified by independent certification bodies like DNV, RENA, and others. And more recently, I've been seeing and hearing a lot more the term reduced CO2 steel, which is still a very generic term, doesn't have a specific meaning anywhere, but it's being increasingly used by players in the automotive industry, both the car makers and some suppliers operating in the segment as well. More specific terms exist, for example, fossil-free steel or clean steel. Fossil-free, of course, produced with no use of any fossil reductant or electricity. Responsible steel is immediately associated with responsible steel as an initiative. So it's still produced at a site certified by responsible steel and that meeting specific progress level on decarbonization and raw material sourcing. You have lower emission steel, which again meets some specific definitions within some of these standards, and even near zero steel, which nowadays is considered to be the state of the art, the most, let's say, ambitious definition of green steel, depending on, again, on the classification system you're looking into. But just keeping in mind that there's potential confusion out there, and always going back to the specific definitions stemming from the terms you're using in the market. And just going quickly through some examples. So this is a table from a paper I recently published with my co-author Hassan Muslemani of the Oxford Institute for Energy Studies. For example, since 2021, so almost 4 years now, SSAB in Sweden has been branding and labeling some of their steel production as fossil-free steel, as I mentioned before. And again, you saw some examples of customers using that product and even marketing those goods produced from the steel from the Swedish company using pilot volumes from their hydrogen-reduced hybrid facility in Luleå. You have other players, for example, in Brazil, Aço Verde Brazil, AVB, obtaining a certification from an independent body back in 2021 as well, of being carbon neutral. So they produce steel using charcoal pig iron, which has a zero or even negative carbon footprint, and then they use that to produce the downstream product that they trade in the local market. And you can see ArcelorMittal with their recycled and renewably produced steel and other steel brands popping out in the market. There are many other examples of actual green steel products and terminology being used in our paper. But broader than that, there are many initiatives and standard setting bodies involved in classifying or standardizing concepts around green steel. None of them, with one exception, which I'll mention in a minute, specifically defines green steel, but they will all be trying to propose and promote and foster broader decarbonization, in some cases deep decarbonization in the steel sector. The most recognizable standards, in my opinion, are Responsible Steel, the Global Steel Climate Council, and Low Emission Standard Steel. They all have different approaches and different, let's say, scopes. Some of them will focus exclusively on carbon footprint. Others will touch on other environmental and sustainability characteristics of the production site or of the product, but in any case, they try to address sustainability credentials of steel. And more broadly, multilateral and some national initiatives getting involved as well. I think initially, most importantly, the IEA, maybe around the 2020s, came up with a proposal for near zero materials that includes steel, but touched on cement, aluminum, and others as well. And I think that inspired the approach used by many other initiatives and standards in the sector. And as I mentioned a couple of times already, but as of December last year, India was the first country through its Ministry of Steel to impose a specific definition of what is in the country to be classified as green steel. And of course, that's immensely important because that's going to inform procurement decisions at public sector level, potentially at private sector level as well. It's to be seen whether this will be actually adopted by market participants outside or around India, or if other countries will follow as well. Buyer coalitions like First Mover Coalitions. I'm very happy to have Andrew today in the call as well to go deeper into the Climate Group Steel Zero Initiative, and some other initiatives like the Raw Materials Institute, Sustainable Steel Buyers Platform are just examples of how these things are stemming not only from policymakers and the producers, but also from the demand side of the steel market as well. And I decided to show you some examples of what these green steel related labels look like. So these are actually actual labels based on these standards and certifications. recently obtained by steelmakers. So first one at the top left is a certified product labeled under the GSCC standard obtained by Steel Dynamics, a US mini mill producer. This is certified by a third party, independent third party, and they claim, as you can see, there's a value of emissions per ton of product produced in this site of 0.97. That's a flat steel product produced last year. It doesn't give more information whether only scrap was used or other raw materials were used, whether that this was used in some specific applications, etc. But it serves as an example of how market participants are actually seeking certification on green steel products and using that in their commercial arrangements. Another example on the right-hand side is Big River Steel, which is again a US EAF-based producer who obtained the first product label from Responsible Steel, I think mid last year. And as you can see, it gives a bit more information in terms of not only their carbon footprint produced in that site that year of 1.34 tons of CO2 per ton of steel product. It also gives the information on the amount of scrap used in that site that year, which in this case is 57.3%, also implying that around 43% of ore-based metallics were used in the process, and then placing this player in the Responsible Steel decarbonization scale. So it's basically a 2x2 chart showing the carbon footprint, but also the scrap share, and then implying that this player achieved as a minimum progress level 1 in decarbonization according to that standard. And finally, more recently, September last year, only a couple of months ago, the European low emission steel standard certified Salzgitter plates and a few other European players on their steel products as well. In this case, again, they achieved E classification, which again, if you think of your light bulbs you buy in the supermarket or washing machines, they have this kind of a ABCD classification system. In this case, they achieved the least stringent ones, but they still achieved it under 100% scrap. They don't disclose at this stage the specific carbon footprint of that specific player or site. And the final messages around this topic would be, harmonization in emissions accounting methodologies is progressing. It's still lacking, but we see some good examples. For example, the Sustainable Steel Principles by the WTO. We have convergence in definitions in green steel, unlikely to fully take place anytime soon, but promising convergence taking place. For example, some recent partnerships announced by Responsible Steel, LAS, and the Chinese Steel Association own methodology, and the scrutiny over these green claims, so what players can call green iron and green steel, increasing. Example, countries in India being quite strong about that, and I think market participants are needing to prepare for an inconsistent landscape in terminology and decarbonization. And higher transparency, of course, is a key competitive advantage of someone who can differentiate. I'll just quickly go through the second topic, and then I'll skip the third topic. I'm happy to go through that with anyone who wants to follow up. Just to mention that, as you will know, the European CBAM is starting next year. The timeline is quite clear. There will be liabilities from importers from the 1st of January, even though payments will only take place later in September 2027. There are many new things that came up yesterday, the benchmarks, the default values, the rules for implementation. So there's a lot to digest and to understand, but the key opportunity for market participants is to disclose the actual emissions, especially if they produce low carbon steel, low carbon materials in general, because then they will be able to avoid the hefty default values. And just to give a hint to finalize on this, the market opportunity for green steel stemming from CBAM. This is just my understanding of the CBAM format as it is now. No need to go through the maths behind it quickly, but in short, the CBAM formula is nothing more than a price on the emissions imported, right? So you multiply the quantity of emissions imported in the good times the carbon price in Europe with some adjustments if there's a carbon price in the exporting country, which nowadays doesn't happen almost anywhere. In the case of hot rolled coil steel sheet products, the default value, for example, for China is quite high. It's about 3.19 tons of CO2 per ton of product. And then if you deduce some allowance for the benchmark that free allowances are based in Europe, and multiply that, let's say, for an assumption of €80 per ton of carbon price in Europe next year, then you get 173 euros per ton on CBAM charge, again, if you're importing Chinese hot rolled coil into Europe next year. That's the amount of tax cost that a Chinese steelmaker can avoid if they are exporting low carbon steel. And how low? Well, specifically in this case, it has to be lower than the benchmark of 1.37 to qualify for a zero credit. Even if it's a bit above, they will still be able to reduce this charge. So there's, again, an opportunity for market participants to benefit from low carbon production routes and materials, not only the financing and the policy side, but also from a market price as well. And with that, I'll end my presentation. Thank you very much for your time, and happy to address any questions.
Paolo, thanks very much indeed. Really, really interesting once again, and good to look beyond the water, what's happening elsewhere as well. Really good to kind of focus discussions as well. I'm sure there's lots there for the Q&A. Conscious of time, so I'll move on very quickly. Joachim, delighted to have you here from Lind, and yeah, really interested to hear what you have to say. I know you recently reached deal to supply industrial gases to the world's first large-scale steel plant, a green steel plant in Boden, Sweden. That's really interesting. So really excited to hear kind of what's happening on the ground there around green steel projects. So Joachim, I'll hand over to you now. You're very welcome.
Thank you very much indeed. Hi, everyone. Thank you so much for joining. I'm Joachim von Schele. I'm with Linde. For those in the UK, we are trading as BOC in the UK. We are the world's largest industrial gases company, and we have been involved supporting our customers through many of the hard-to-abate industries with solutions for many years. So let's discuss a bit on steel and the task we have before us here. And I pull up a screen here, pull up a slide on my screen here. I hope you will be able to see that one. But before diving into details, let us define what is the task here. So it's about decarbonisation, and it's about decarbonisation of the steel industry. But if I look across Europe, and we can see a big reduction of CO2 emissions from steel industry over the past few years. However, that is because of deindustrialization. That is due to reduced output. And of course, that is not what we would like to do anywhere in the world. We would like to maintain the industry, but have a cleaner industry. So we have to think about it from that type of perspective. How can we do a change which doesn't mean that we are losing jobs, that we are losing industrial infrastructure? And this is being more and more pronounced, of course, politically considerations, geopolitically, and also when it comes to supply chain security. So it's a challenging task, of course, to do that. And that then brings us into the question of pathways. And I think we can separate between what we can do today, what we can do immediately, and what takes longer time. And there are multiple pathways for sure, and Frank and Paolo have already touched upon this. And there are various solutions, and they can be implemented in different steps. Not all of them are suitable at every location, etc. There are various preconditions, and we can have parallel developments. We can develop new processes at the same time as we are implementing what we have at hand today. So altogether, there is no silver bullet. There's not one size fits all here, and we have to look upon it very individually, how we can maintain steel production and those sites that we have already to ensure that people keep their jobs there and being competitive, still being greener. Of course, if you look in general, there is electrification. Of course, we should do electrification wherever we can, but it's not suitable for all the processes in the steel industry. So wherever we can, that's number one. But otherwise, what we are working with, as what you will see here on the slides, is to improve the energy efficiency. And this is something we can do immediately. We do that today. And then we can look at other type of solutions that we have at hand. We can use low carbon fuels that can be generated from waste incineration, for example, and so on. And then we talk about carbon capture and hydrogen. This is something that we as a company has a lot of experience from. So this is not things that are, from any utopia. Carbon capture, Linde has dealt with for a number of decades. The biggest carbon capture installation we have in the steel industry handles a flue gas stream of 500,000 cubic meter per hour today. It has, and you can capture more than 90% of the CO2 in those streams today. There are a lot of references. So this is something where there is experience, there are proven solutions. Same with hydrogen. Hydrogen, Linda's been with hydrogen for more than 50 years. We have more than 230 plants that we operate across the world. And so this is nothing new with hydrogen. What is new with hydrogen is some of the uses of it, and it's about the scale up of the supply to make that happen in a viable way, of course. So then, of course, we should also think about how that hydrogen comes there, not only being viable and at scale, but what is the carbon footprint of it. And here is something that is very important in general, and that is that we have a legislation that is neutral when it comes to solutions. I mean, it doesn't matter if the cat is black or white, as long as it catches the mouse, right? So we have to think about how do we get that hydrogen supply in place. People talk about blue and green hydrogen, and I would say that in most locations in the world, there is a possibility to have a blue hydrogen supply, meaning that it's based on natural gas combined with carbon capture that has a lower carbon footprint than using grid electricity and an electrolyzer. And it's several times lower. Across Europe, I would say that at least Western Europe, we can supply today hydrogen based on natural gas and carbon capture that has a carbon footprint of around 1 to 2, whilst if we put up an electrolyzer at many places, we will have something that is have a carbon footprint of 5 and higher. And I would say that goes for the UK, for example, as well. So that's very important to keep in mind. This terminology with those colors could create a lot of confusion. It's very important that we look at having certification of what is the real carbon footprint and also the possibility to scale it up. Because if you look at iron making, we need a lot of hydrogen if we will use solutions with that. That could be, of course, to inject it into blast furnaces to a certain extent. We have been involved in that over time. But of course, as already touched upon, using hydrogen for production direct reduced iron, and that is not that big a step technically, but it requires a viable supply. But first and foremost, we should look at carbon capture in this context. I would argue that carbon capture is the benchmark. I mean, the first thing we should explore at an existing site is to see if we can do a carbon capture and at what cost. What we have seen is that in most locations in the world where it's possible to do a carbon capture, that is also the cheapest solution. I know that some people argue against this from various perspectives, but I think it's worth exploring it, definitely. We can use low carbon fuels also here. We can gasify waste and use that for the reduction, for sure. And we could use DRI, HBI, hot briquetted iron, also in a blast furnace to reduce the carbon footprint of an existing blast furnace. We should not forget about that part of it as well. So this is the iron making then. And of course, what we might not want to do is to outsource the iron making, but we see this is happening increasingly at many places that you say that, all right, we do only the steel making part and we let the iron making take place elsewhere in the world. We are breaking up the supply chain. It will import the direct reduced iron, probably in the form of HBI, from somewhere else and bring that to your site. Well, you can do that. It's good for a carbon footprint. It's the best way to do it for many, but it also has severe political consequences. And I would argue that over time, it actually means that also we have a mission creep here in terms of that also the steel production will go to those countries where these iron units are produced. So you need to be very much aware of that when arguing about breaking up the supply chain here. And then on steel making and downstream, there is a lot that we can do already today, and all these electric arc furnaces, ladle breeders, reheat furnaces, and so when it comes to doing fuel saving. And that is by increasing the energy efficiency, going from air fuel combustion to oxy-fuel combustion, and doing that in a fashion so we can then be ready for using hydrogen. So first we fire less, and then we fire with the clean fuel. This type of transitions are taking place at many places, and we talk about reducing the carbon footprint by around 30% on average in the first step. And I would then highlight that going from air fuel to oxy-fuel combustion is a bigger reduction of the carbon footprint than blending in 50% hydrogen into a natural gas fuel and using air fuel combustion. And it's much, much cheaper as well. So it's much more efficient to do this type of step. And then, of course, in the second step, when there is a viable supply of hydrogen, we can use that for those various operations for melting and heating. And I give you one example of this from reality. This is a project we worked with together with the steelmaker Ovako. This is from their site at Hofors in Sweden, where since last year, all the reheating in the soaking pit furnaces are taking place using 100% oxygen plus 100% hydrogen. This works very well. Since it started up almost 2 years ago now, 500,000 tons of steel have been produced in this way. And there is an electrolyzer on site, which is supplied by renewable energy. And so the oxygen, the hydrogen that goes in there has zero carbon footprint. So I think this is a very well-defined, very green steel that comes out of this. And again, an example from reality, more than 500,000 tons of steel have already been produced here. So we don't talk about any ideas for the future. We talk about reality in the same fashion as we talk about reality when it comes to carbon capture and the other solutions. There are a lot of great examples there. We need to have a legislation that is supportive to this. We need to dare to take these steps also. But we have a rather low risk due to the many installations that are there. If I take Linde as an example, we have done more than 600 installations of oxy-fuel combustion in the steel industry. So I think that is something that we can do already today. In parallel, of course, we should work on developing new processes. There is no conflict between the two, and we should work on making sure that we have a technology neutral legislation. And I stop there. Thank you very much. Happy to take your questions. Thank you.
Joachim, thank you very much indeed. Another really interesting presentation. Interesting to hear the work that you're involved in. That Ovako plant seems really interesting as well. Excited to hear a bit more about that in the Q&A session. I'm conscious of time, so I'm going to hand straight over to Andrew. You're very welcome, Andrew. Excited to hear about the climate group and Steel Zero and the projects that you're involved in as well. I'll hand over to you now.
Thank you very much. Joachim, would you be able to just unshare your screen a second? So I've still got, hesitate to say unshare because it means you all get to see me. But thank you very much, everyone. So I'm Andrew Forth. I work for an organisation called Climate Group. We're a global non-profit based in London, and I'm here today because we run an initiative called Steel Zero, where we work with steel buyers who've made a commitment to decarbonising their steel purchasing with an aim of buying 50% of their steel being reduced emission steel by 2030 and aiming to get to as low as possible emissions by 2050. We work with companies in the construction, automotive, consumer electronics, consumer goods, people buying everything from as big as a oil tanker and a cargo ship to as small as watch parts. We do this because I think everyone who's on this call knows the steel industry can't be transformed without its customers leading the way and helping finance this change. I think when I was reflecting ahead of this webinar, I thought to myself, the UK is a pretty small steel maker in the global context, but I think it's a very important one in a number of ways because the discussion we're having in the UK today is one that a lot of other countries are going to be having in the years to come. And that is, how much do we really want to be able to make steel in our country? You may have seen earlier this week, or maybe it was last week, the UK government announced that it's basically spending £1 million a day to keep the relatively small steelworks in Scunthorpe online and producing steel. That's a staggering amount of money, and one which in the long term, I don't know how they're going to find a way out of. I think it's highly unlikely anyone's going to want to buy that site. And I think what's probably going to happen is the government's either going to have to close it and take the political hit, or build the EAF there itself and then sell it off for pennies in the pound to somebody who wants to take on the risk. That's a risk that the companies we work with are really worried about, because companies that they've been buying steel from for, in some cases, nearly a century, are starting to look less secure. If you're based in Europe and you're wanting to buy electrical steel, the news from ThyssenKrupp Steel this week that they were consulting over the future of their electrical steel business should be a real warning sign. The steel is here today, but the steel industry is in a pretty catastrophic state, and we need to find a way to support it. So how are steel buyers looking to support the steel industry? Well, the first is that we are working with them to get better data about the steel they are buying. Even now, it's pretty hard to know the emissions profile, the scrap quantities, the production details about the steel that you buy. Paolo shared some slides earlier from some of the real cutting edge steel makers who are providing that data. But in a lot of the world, you can't get that. We need to have good standards and we need to be applying them. It's really positive to see the recent announcement that Responsible Steel, LESS, and the Chinese Iron and Steel Institute have been sort of working on making their standards more interoperable and working together. For a global commodity like steel, as Frank mentioned, this is one of the most traded commodities in the world. Having that global ability for a steel buyer to compare product A with product B is going to be absolutely essential. The second thing that we're really hoping to do is drive a transition. This isn't going to work if all we're doing is decarbonising the easiest bits, and there are some companies out there buying small quantities of super low emission steel, and in the background you've still got a huge amount of blast furnace steel being produced. That's going to mean actually investing. It's going to mean moving past offsets, moving past using some of these slightly dubious carbon accounting techniques which we're seeing applied to some steel products. And I think this matters because steel is inherently very, very political. I don't think any other business would be getting this level of support to keep such a relatively small number of jobs going in the UK. It's about 2,500, 3,000 direct jobs, £1 million a day. That's a fairly epic contribution at a time when public finances are incredibly stretched. So from our perspective, the steel buyers are asking governments, what type of steel does a country want to be able to make competitively? It's not about what we can technically make. You can make almost anything in an EAF at the moment if you've got the right feedstocks and you've got the right ability to produce in small quantities. But the reality is, if you're looking to buy steel in Europe, the signs aren't positive at the moment. So many of the hydrogen-based steel products are being delayed or cancelled. And what we're seeing is companies looking to China, looking to Latin America, looking to people like Meranti in Thailand, who are bringing green steel plants online or have concrete plans to do so. And I'm not sure there's a really clear answer from the European steel industry as to how they're going to tackle this. Joachim's point earlier around the dislocation of iron making was, I think, a really interesting one. How economically feasible is it going to be to make hydrogen and use it to reduce iron in Europe? Does it make more sense to do it in Australia, in Brazil, in Guinea? Places like that where producing renewable electricity is going to be a lot cheaper than it is in Europe. So what would we like to see governments do? The first of all is government needs to start using its purchasing power. Government buys directly and indirectly a huge quantity of steel. 50% of steel is in construction. In most countries, a significant percentage of the construction market is either directly related to government as a customer or is highly regulated. We want to see embodied carbon standards that progressively drive steel decarbonisation. Secondly, we want to see a much greater usage of lower emission steel in products and markets which directly link to the decarbonisation of the economy. There are many challenges with what the EU announced earlier this week on the electric vehicle phase out, but it was interesting to see them suggesting that one way that manufacturers could keep on using combustion engines was to use green steel in the production of those vehicles. If that is something that really drives investment from a steel perspective, that could be a good thing. If all we see is low value parts, stuff which is already recycled content being just flagged as recycled, it's not going to help anyone really. It's not going to help the environment. It's not going to help Europe's steelmakers. And it's ultimately going to be another reason why Europe's automotive sector is becoming increasingly uncompetitive. Final thing, because conscious of time, is in the expansion of CBAM that was proposed by the European Commission earlier this week, there was one thing buried deep in the details, and that is that pre-consumer scrap is now going to be treated as a material for CBAM purposes. And that is going to pose an enormous challenge for some of the efforts in Europe to decarbonize steelmaking through just recycling. It's a sort of dirty secret that a lot of the people making high grades of automotive steel in electric arc furnaces today rely very heavily on pre-consumer scrap. That's going to become subject to CBAM now. And certainly in the UK, where we simply don't have a significant pre-consumer scrap steel market, and in other countries, that's going to really push up the price of taking this route towards decarbonisation. So, as I say, going back to my first question, governments need to start asking, do we want to be able to make steel? What do we want to be able to make? And how are we going to support that industry in the long term? Businesses want to help, but unless the policy framework is there to support both the investment and the demand, it's going to be a very hard challenge. And for a lot of businesses who are on the supply side, I'm not sure how much time they've got before the business becomes very, very challenging for them. I'll leave it at that. Some excellent presentations today. Thanks for inviting me, and yeah, good to see what questions we've got.
Andrew, thank you very much indeed. Some really, really astute points there that I think really need fleshing out from certainly from a policy level, but it's kind of you know, I like your point that steel is a very political issue, and I think that's true, and I think there's good reasons for that. I mean, a question I have is, you know, just on that point, is kind of country do you think, and I'm interested to hear what our other panelists think as well, can a country realistically kind of claim to have a secure net zero transition if it no longer controls the production of a material as important and fundamental as steel? I mean, you know, we saw in the summer that the UK nearly lost its ability to create its own primary steel. That should be quite a big concern, right? And you know, I suppose that would be where I'd start in terms of a kind of a broader question around green steel. Frank.
Yeah, it's a good question. So I think kind of fundamentally, kind of you can say, do we need to make all steel that is available? No, we do not. There's about, what, 3,500, 4,000 grades of steel. The UK steel sector was never going to be able to make all kind of steels that's available. We will always need to import some types of steel. That is just how it is. Similarly, in the way that there's some grades that the UK produces that is the only producer of that type of steel in the world, and being the only supplier of that in the world. So in a way, we do have to leave behind this imaginary kind of world where we can be completely self-sufficient. However, if we are kind of do lose our steel industry, we will be the only kind of major economy and only G7 economy, really only G20 economy without a steel industry, because steel is so essential to it, and it's essential to most of our supply chains, manufacturing industry, essential to a modern economy, and you will be wholly kind of dependent on foreign suppliers. And we saw that being in particular risky during the COVID-19 disruptions of global supply chains. And when Russia invaded Ukraine, suddenly you became very worried about kind of that kind of reliance on foreign suppliers. I think in terms of kind of the primary steel making, from a UK steel perspective, we are less concerned in terms of kind of whether the UK has a primary steel maker. We can make kind of broadly kind of 80 to 90% of the grades of steel that we make in the UK currently with electric arc furnaces. But from a global perspective, we do need to kind of decarbonize primary steel making. And you could kind of say, as I kind of said in one of the questions too that was posted in the Q&A bar, has the UK effectively opted out of the difficult challenge of decarbonizing primary steel making if it just kind of wholly electrifies? On the other hand, we are quite small as a kind of steel industry, and we wouldn't be particularly exposed from it. So
yeah, thanks, Frank. That's interesting. I've got some points I'd love to elaborate on there, but I don't think we have time. So Joachim and Andrew, I'll bring you both in now for a very quick addition to that, please.
Yeah, thank you. A couple of quick builds. I mean, we see on a company level, we see a kind of backward integration into the supply of raw materials going on since many years, and we see steel companies buying up companies in the scrap industry, for example. We also see certain of the integrated producers also going back and taking control of mines at various places. So on a company level, definitely securing the raw material and then securing, of course, scrap, not at least, is extremely important, being a key to the green steel transition. And then of course, you have the political aspect of it, and I touched upon it, and Andrew and others as well. I think that what we might see is a development, as we see in general, a kind of spheres of interest here, actually, certain tie-ups between various countries and so on and so forth. But that could also be paired with that certain countries are putting up a ban on exporting scrap to a certain extent, at least, to make sure that the steel producers in their own country has the chance to get that scrap first and foremost.
Yeah, thanks, Joachim. Andrew.
Yeah, I think it's a really good question you've asked, Tiernan, around the security of the transition if you haven't got that ability. And I think the knock-on impact of the UK losing a steel sector on manufacturing, it becomes another reason why manufacturing businesses face a challenge in the UK. We already have the high energy prices, the trade barriers that Brexit has introduced. None of these are generally positive things for the business climate for manufacturing in the UK. Uncertainty around where your steel is going to come from, and that link between, you know, innovation and the sort of the cluster value that having these things together can bring. I think it's a really big question, but we need to have that conversation. And I think for me, one of the big challenges in the transition to EAF is that it is technically possible to make these things. Is it commercially viable to make these? And if the steel production in a country is heavily dependent on subsidies or market distortion, that becomes very subject to political trends. You know, a trend today politically might be successful. If we get a new government that commits to massive reduction in its spending, how likely is that to continue? So I think ultimately our aim needs to be a sustainable steel industry financially, and part of that for me is looking at, can it make the grades where the steel makers can make their profit? Because if the UK is dependent on volume and low quality or lower quality, then financially we just can't compete here with other companies.
Thanks, Andrew. Paolo, is there anything you want to add there before I move on to the last couple of questions?
No, happy to go on and for the interest of time.
No bother. Perfect. So there's a couple of questions that I can see that Frank, you've answered. One around the development of CCUS. That's really seen some success recently, I think, in the UK, kind of moving beyond a sequencing approach more to a wider market approach, which is great. The question was, are you seeing an increase in interest of utilizing that for steel making? I think you mentioned that British Steel would be the most viable option there as well. Another question I saw on does the UK Steel have an idea of the level of reduction in electricity prices needed? And you've given a very comprehensive answer there, so I'll point people there. Just a few more questions then. I'm wondering if we can take them all now, and if anyone wants to come in on them before we close. So a question from Jesse Baguli here for yourself, Joachim. This is about the UK, so I'm not sure how much you'll be able to say here in terms of the UK approach, but you might have something more general to say. Are there any thoughts to reintroduce ammonia plants where they've been previously removed within the UK? This is using both your own previous assets, but also others. So that's the first one. For Andrew, there's a question here. With pre-consumer scrap, which you mentioned, falling under CBAM, how would that impact the global scrap market and in turn the UK scrap market that mostly exports outside of Europe? And a final question here from Anise Gambold. In order to switch to EAF or DRI, you mentioned construction times, but there is also a lead time on. Is there also a lead time on top of that, i.e., from when a subsidy is set up to the company setting the wheels in motion? So 3 final questions there, kind of discussing different things. Joachim, I wonder if we could start with you there.
Sure. Happy to do so. Yeah. Ammonia relates to hydrogen here, and we should keep in mind something very important, and that is that when we talk about gases, there is also the issue of transportation of gases. Hydrogen in general should be produced and used at the same location. It's very tricky to transport hydrogen, and comparing to transporting CO2 back to carbon capture, CO2 is easy to transport. In that context, ammonia has been highlighted and saying that, well, what about if we produce ammonia, green ammonia instead, and transport that? I would say that from an energy point of view, that is not perfect. It's not a very efficient way of doing it. It's possible, and then turn it back into hydrogen at the end. And to the question, would there be a possibility in the UK to produce ammonia? Yes, we could produce green ammonia for sure. That means that we are applying carbon capture, and I'm a big advocate for looking into that option all the time. So yes, that is a possibility. But in the case of using hydrogen for the steel industry, then we should produce so-called blue hydrogen directly on site in that case, rather than going into ammonia. I don't see ammonia playing a big role in the steel industry going forward. It's used in heat treatment applications, and some people again are arguing that it could be used as a means of transportation for using hydrogen, but I don't see that really happening. So starting up ammonia plants for the sake of decarbonizing steel industry, I doubt that would be the case happening. I cannot, as you mentioned, comment exactly on everything in the UK, but I think it would be challenging to make a reasonable business case based on those assumptions.
Thanks, Joachim. And then I suppose just finishing then on that point around the pre-consumer scrap falling under CBAM. Andrew and Paolo, I wonder if you are the best to possibly comment on this. And Paolo, just one last thing. There's a question there around perspectives on the biggest challenges in standardizing data available to buyers as well, particularly on emissions intensity and its relation to CBAM. I'm wondering if we could finish on those 2 points if possible. So the pre-consumer scrap and then that standardization of data aspect as well. So Andrew, I wonder if you want to come in then first.
Yeah, I think the scrap issue, this feels to me like a first step towards much greater regulation of scrap flows. I know that it's increasingly seen as a strategic raw material, and there was a lot of pressure on the European Commission to impose much greater restrictions on scrap exports. I think from the UK perspective, we don't have significant quantities of pre-consumer scrap floating around in the UK market relative to some other markets. It's one of the big barriers to the adoption of EAF steelmaking for higher grades, high quality grades here. And the stuff that we do have, we export a lot of it because the price that's available in markets like the US, where there is a large EAF sector, are pretty substantial. So I think it's what's available today on the global scrap market is probably not going to be what's available in 5 years' time, as we see a lot more resource nationalism, in my view. I'll leave it at that.
Thanks, Andrew. Paolo, last word to you then.
Yeah, thanks, Tim. So the new announcement yesterday on including pre-consumer scrap, I think both for steel and aluminium, specifically as a precursor. So not I think not related, in my understanding, to the trade of these pre-consumer scrap products itself, but when goods are imported into the EU that were produced in there or pre-consumer scrap, then there's going to be I think the purpose is a way for the European Union to avoid circumvention of CBAM charges by, again, steelmakers using for increased use of these pre-consumer scraps. But I do agree with Andrew that there is a component of maybe trade restriction, trade policy there, because again the world is turning to more restrictive, less open to trade on scrap, given its strategic importance for decarbonization. And I think that the data quality, the data consistency point you mentioned, Tim, and is very important. We see very different, let's say, approaches by countries on whether these kind of materials information or environmental information are required for disclosure for listed companies in specific stock exchanges. Notably in the US, there's normally a lot less transparency than in other countries for that to be made required. However, customers are much more vocal in terms of requiring these things directly from their customers. So what I see as a market observer is an increasing need for public repositories of emissions data, of intensities of corporate emissions and target as well, and that's been a strategic advantage for those who can publish early on.
Paolo, thank you very much. Folks, we're very much out of time. Unfortunately, there are a couple more questions in the chat there that unfortunately I haven't been able to get to. Apologies for that, folks. Frank, I've seen you've sent some very interesting responses there, so thank you for that. If any of the speakers did want to take a look and pop any in, then please do feel free. But with that, as I mentioned, we're very much out of time. What an interesting conversation that certainly could have gone a lot longer. And I think one of the takeaways from this as well is that there is certainly a conversation to be had there around CBAM itself. It seems like something that's come through again and again, and it'll be really interesting as well post EU CBAM to see how the UK CBAM links to that as well, especially in such a global industry as well, and see what alignment needs to happen there as well. But folks, thank you so much for sharing your thoughts and your really interesting presentations. It was a pleasure to listen. I hope you all enjoyed it from the floor, and thank you very much for joining us, for your really interesting questions too. I think we'll leave it there, but certainly will not be the last conversation on green steel and industrial strategy. As I mentioned, this is a very fundamental part of our conference taking place in February, and I'm sure the conversation will be continuing then. So if this was of interest, do consider joining us in Liverpool then as well. But for now, I'll say thank you again for joining. We'll leave it there, and I hope you have a good rest of your week and weekend when it comes, and a lovely Christmas as well when it comes. So thank you very much, everyone, and take care.
Thank you.
Thank you.
Thank you.
Thank you, everyone.
Thank you.